I would like to welcome you all in the lecture series of Basic Electrical Engineering. In this session, I'm going to discuss one of the important problem on transformer efficiency. This can be asked in the competitive examination, especially in the GATE and various university examination. Now let's get started. I request everybody to read the question and understand the concept very well. So also parallelly write the given data. So by the way, I wanted to provide the given data first. Let me write the given data. So I request everybody to casually go through the question and the given data. You can write the given data. A 40 kVA. So kVA rating of the transformer. What is the kVA rating? It is 40, right? 40 kVA transformer, kilovolt ampere. Usually transformer rating is expressed in terms of kilovolt ampere. It has the core loss of 450 watts. So let me write it. Core loss that is equal to iron loss or iron loss. We can write like a 450 watts. It is very clear. Also, the full load copper loss. Let me write WCU. WCU that is equal to how much? It is 850 watts. Okay, 850 watts. If the load power factor is equal to 0.8, so let me write load power factor is equal to 0.8 horse 5. Calculate the efficiency at the full load. Okay, that means efficiency. I'll be writing X is equal to 1. That means the fraction of load is equal to 100% or that is equal to 1. So what is the formula? The formula is very simple. Like that we already discussed in the last session. That means X into kVA cos phi. That is equal to output, right? Output. Output divided by output plus losses. That means input, right? So let me write X into kVA cos phi plus iron loss. Let me write Wi plus what is copper loss? X square into WCU because copper loss that will be directly depending on the load current. So by the way, let us directly substitute the value. What is the value of X? Since it is full load, let me write 1. 1 into kVA that how much 40 it is and the power factor is 0.8 divided by, okay, only substitution that is pending. Same thing, 1 into 40 into zero point 0.8 plus WI is how much? 450 watts. 450 plus 1 square. 1 square into 850, correct? If you substitute directly and finding out the answer, it will be 96.091 percentage. 091 percentage. I request all the viewers and my subscribers kindly verify the answer because it's most important. Second one is first part is over. Now I would like to discuss about the second part. Okay. So please make a note of this. 96.091 percentage for the first answer. Now I'll be rubbing the screen. Yeah. Let me discuss about the second part. So I request everybody to pay the attention. While talking about the second part, the load at which copper loss is equal to iron loss. So if I talk about the condition for maximum efficiency, we'll be writing like a iron loss that is equal to copper loss. That means X square into WCU because X square is mandatory. Why? Because like the copper loss that will be depending on the load current. From this I can calculate X square. X square is nothing but Wi divided by WCU. Therefore, we'll be writing the fraction of load that is equal to square root of Wi divided by WCU. I request everybody to substitute. I'm talking about the second answer. Load I need to calculate. Correct load. That means X. That is equal to Wi. How much it is Wi? It is 450 watts. 450. What is WCU? It is 850 watts. 850. So I request you to simplify this. So once you simplify, you will be getting 0.7276. 0.7276. That means X is equal to, in terms of percentage, it is 72.76 percentage. At this load, you can expect the maximum efficiency for this given transformer. That is a specialty. So fraction of load that is equal to 72.76. What is your third job? Efficiency at this load. Efficiency at this load means efficiency at 72.76 percentage. Can you calculate? Of course, I can do it. So let me clear it off. I wanted to rub. So I'm talking about the third part. So choose X equal to 72.76 percentage. I'll be rubbing the board. You can note down the correct answer. So no need to worry. Yeah. So again, please write down the formula. The formula is eta. Eta is equal to eta at x equal to 0.7276. That means x into x means 0.7276 into kVA is 40 into cos phi power factor, that is equal to 0.8 whole divided by same term 0.7276 into 40 into 0.8 plus Wi. What is iron loss? Iron loss is nothing but 450 watts, right? 450 watts. Iron loss and copper loss is same only, don't get confused. What about copper loss? It is 850 watts. That means x square into 850 watts. What is x? X equal to 0.7276 the whole square into 850 watts. So if you want to multiply with 100 to get in terms of percentage. So I should get 96.729. 96.729%. Kindly put your answer in the comment box so that session will be more interactive. So that's all about this problem. You can expect a similar kind of problem in the forthcoming competitive examination as well as university examination. If you have any queries, please do let me know through comment box. Even you can mail me. Also, I am conveying my gratitude or thanks to watch patiently for completion of this video until the completion of this problem. If you are watching our channel first time, kindly subscribe. Also, if the content is useful, I request you to share with your concerned stakeholders. Thank you so much for watching this video. Happy learning. Have a great day. Thank you again.